Welcome back, everyone. This is still a physics lesson on electricity. Amara is my name on Akada Store. So right now we'll be investigating Ohm's law. In your lesson notes, I gave you the formula V equals IR. You could put it simply this way that the voltage in a circuit is directly proportional to the current, and then okay, let me say the current in a voltage is directly proportional to the voltage and inversely proportional to the resistance. It means the greater the voltage in a circuit, the greater the current. The greater the resistance in a circuit, the smaller the current. Okay, so we're going to investigate that theory here. Now, what is voltage? We you remember some of the analogies I gave you. It's like your battery is like power provides the surge, the energy that pushes the electrons in the circuit. That's what your battery does here for you. So if you think of a water pressure, if you're looking at waterfall, that water pressure is like likened to this battery that pushes, gives the water the push it requires. A resistance is that which opposes the flow of electrons in it. So it's like the electrons flow from here encounter a resistance depending on the amount of resistance that they encounter will depend on how much will flow through it. So a resistance, that's as simple as it sounds, resists the flow of electrons in it. Okay, so Ohm's law is that V equals IR. The greater the voltage, the greater the electricity, the greater the electricity, and then the greater the resistance, the smaller the electric current that will flow through. So we're going to investigate that. Then we'll compare that with the formula. You can also generate some data, and make a graph out of this. Okay. Now I'm going to close the circuit now, and then you can see that your electrons are flowing. Now what I'm going to do is I'm going to, first of all, I'm going to get an ammeter here, right? And I'll put it here. I'll put it here. So this will show us the reading on the current flowing here. So I'm going to change this. In an experiment, you vary one thing at a time. That thing that you're varying is independent variable. The one that depends on that particular variable is called the dependent variable. Always know that. Okay, so I'm going to start from as low as 7 volts. Then we'll see, you look at the output, the current reading. Now watch what happens when I'm keeping the resistor constant. I'm changing only the voltage of the circuit. Now watch what happens when I increase the voltage. Look at the ammeter reading. What do you observe? What do you observe up until this point? Okay. V equals IR. V is directly proportional to current. Does this answer that question? Does this support that theory? Alright, so the next, let me move this down. The next, I'm going to keep the voltage stationary. Then I'm going to vary the resistance. Okay, right now, the current in the circuit is 3.1 ampere. Now we're going to vary the resistor. The resistor currently is 10 ohms. So we're going to increase that and see the effect it has on the current in the circuit. You can see that there's a drop as I increase the resistor. The current in the circuit drops, and you can see the flow of the electrons gradually slowing down. If I reduce it, however, see, it starts increasing. So does that answer the question? Right? That's the question now I'm going to ask you. The first one is that, is it true that the higher the voltage in the circuit, the lower the current? Is that true based on Ohm's law and based on the simulation that we just did now? What do you think? Is that true? And then is it also true that the lower the resistance in the circuit, the higher the current? So sit down and just think about this. Get your answer. I'll drop the response on our discussion page on our cadastre. But I want you to look at this simulation, look at it critically, look at the question, look at the formula. Because see, my aim here is not just is to make the science come alive to you so that you see that it's actually something you can relate with. It's not something you should just sit down and cram. But if it's something you can relate with and something you know, I mean, you will know it in the next 20, 30, 40 years. Nobody can take that knowledge from you. So when I ask you some of these questions, just take some time to just make the effort to get to understand it, attempt to answer the question. It drives it home for you. Even though I'm going to be dropping the answers in our discussion pages, it's this is still for you. You just put yourself to that work and evaluate what we just did. Forget about the formula. What we just did now. Then you now look at the formula. Does it actually match? Does it make sense? That if we decide to get various values, for instance, if I'm saying, okay, let's try various values here. This is 22 ohms. Move it to 20, 22, 20, 20, okay, 21, and then you collect the data. 21, 17, 13. At this point, what is the effect on the ammeter? The ammeter reading, you get these values, you get the same one for the voltage, you measure it, you analyze it by yourself. What does it even tell you? What does it even mean? Okay, if tomorrow somebody wants to build a circuit, what is the person looking at? Because these are the things that engineers look at if they want to build something as simple as your phone. These are things they actually measure. Okay, I want to achieve this amount of power or electricity, or they do this calculation based on some of these things that we've done the simulation on. So I urge you to just think on this and try to answer the question. I'm going to be dropping the answers for you on our discussion page. So I'll see you there.